The universe is a vast expanse, filled with countless celestial objects. Among the most magnificent are galaxies, immense collections of stars, gas, dust, and dark matter. These cosmic islands are the fundamental building blocks of the universe. Galaxies are not static entities. They are dynamic systems. They interact, merge, and evolve over billions of years. Understanding them provides crucial insights into the universe's structure and history. Galaxies come in various shapes and sizes, broadly classified into three main types. Spiral galaxies, like our own Milky Way, feature a central bulge and prominent spiral arms. These arms are regions of active star formation. Elliptical galaxies are typically older and more spherical or egg-shaped. They contain less gas and dust, and star formation has largely ceased within them. Their stars are generally older and redder. Irregular galaxies lack a distinct regular shape. They often result from gravitational interactions or collisions between other galaxies. These chaotic forms can host intense bursts of star formation. Our solar system resides within the Milky Way, a barred spiral galaxy. It spans approximately 100,000 light-years across and contains an estimated 100 to 400 billion stars. We are located in one of its spiral arms, the Orion Arm. At the heart of the Milky Way lies a supermassive black hole, Sagittarius A. Its immense gravity influences the orbits of stars and gas in the galactic center. The Milky Way is part of the local group of galaxies. Stars are born within dense clouds of gas and dust, known as nebulae. Gravity causes these clouds to collapse, forming protostars. As the protostar contracts, its core heats up. When the core temperature and pressure become high enough, nuclear fusion ignites. Hydrogen atoms fuse into helium, releasing enormous amounts of energy. This marks the birth of a true star. Once fusion begins, a star enters its main sequence phase. This is the longest and most stable period of a star's life. Our Sun is currently a main sequence star. The star's size and temperature depend on its initial mass. More massive stars are hotter, brighter, and burn through their fuel much faster. Less massive stars are cooler and have much longer lifespans. Stars like our Sun, with relatively low masses, follow a specific evolutionary path. After exhausting the hydrogen in their core, they expand into red giants. Their outer layers cool and swell. Eventually, the outer layers are shed, forming a planetary nebula. The remaining core collapses into a white dwarf. This dense, hot remnant slowly cools over billions of years, eventually becoming a black dwarf. Massive stars, though significantly larger than the Sun, have a more dramatic life cycle. After their main sequence phase, they evolve into red supergiants. These stars are truly enormous, dwarfing our Sun. When a supergiant exhausts its nuclear fuel, its core collapses catastrophically. This triggers a spectacular explosion known as a supernova. Supernovae are incredibly bright, briefly outshining entire galaxies. The fate of a massive star after a supernova depends on its initial mass. If the remnant core is between 1.4 and about 3 solar masses, it collapses into an incredibly dense neutron star. These objects are only a few kilometers across. If the core's mass exceeds roughly 3 solar masses, gravity overwhelms all other forces. It collapses indefinitely, forming a black hole. Black holes possess such immense gravity that nothing, not even light, can escape their grasp. Galaxies are not just collections of stars. They are also the sites of ongoing star formation. The spiral arms of galaxies, rich in gas and dust, are prime locations for new stars to ignite. Collisions between galaxies can also trigger bursts of star formation. The evolution of stars within a galaxy contributes to its overall chemical enrichment. Supernovae, for instance, disperse heavy elements forged in stellar cores throughout the galaxy. These elements then become the building blocks for future generations of stars and planets. The study of galaxies and star evolution reveals a deeply interconnected cosmos. Stars are born within galaxies, evolve through various stages, and eventually return their material to the galactic medium. This cycle of birth, death, and rebirth shapes the universe we observe. From the grand scale of galactic structures to the intricate processes within stellar cores, each aspect informs our understanding. The universe is a dynamic, evolving system, constantly creating and transforming.